Hi, in this video we're going to be doing some more problems with buffer solutions. So first question asks, what is the pH of solution in which 0.42 moles of potassium nitrite is added to 2 liters of 0.1 molar solution of nitrous acid? Okay. Potassium nitrite is KNO2 minus. Nitrous acid is HNO2. So KOH is a strong acid, which means K plus is going to be a weak conjugate base, so it's a spectral ion. And since it's a spectral ion, we can process out. Now the equation will just be HNO2 plus H2O forming NO2 minus plus H3O plus. And since we're not adding a new substance, we can just use a Rice chart and not a Rebecca chart. So HNO2, we start off with, how much did it say? 0.1 molar solution. So it's going to be 0.1 molar. Remember, Rice chart, you're going to use concentration, molarity. H2O, we skip. NO2 minus is basically KNO2. We just have the K sitting outside being spectral. Okay. So it told us that we have 0.42 moles of KNO2 minus. Now we need to convert moles into molar because we're doing Rice chart with molar. So 0.42 divided by our solution. We did not add a new solution of KNO2. So it's just going to be the same 2L. So we're going to divide this by 2 liters to get our molar concentration divided by 2, which is 0.21. So over here will be 0.21. It starts off with 0.21 because of the KNO2 minus that we added and not 0. And H3O plus on the other side will be 0. So it'll be plus, no, this is going to be minus x. 0. minus x. It'll be plus x. Plus x. 0.21 plus x and x. So Ka is equal to concentration of H3O plus times the concentration of NO2 minus divided by the concentration of HNO2, which will be equal to 0.21 plus x times x divided by 0.1 minus x. Now let's check out the K for HNO2. It is 4.0 times 10 to the negative fourth. So 4.0 times 10 to the negative fourth is equal to 0.21x divided by 0.1. And we remove these two because of how small our K is. So 4.0 e to the negative fourth times 0.1 divided by 0.21 gives you an answer of x is equal to 1.90 times 10 to the negative fourth. And take the negative log of that, which will be 3.72, and that is our pH. Next, how many grams of ammonium chloride? Ammonium is NH4Cl. Ammonium chloride needs to be added to 1 liter solution of 2 molar to ammonium hydroxide NH4OH to create a buffer solution with a pH of this. Alright, so let's quickly write the HH equation. So pH equals pKa plus the log of conjugate base divided by acid. And this can also be rewritten as POH is equal to the pKb plus the log of conjugate acid over base. So yes, there are 2 ways you can write the HH equation. One gives you POH, one gives you the pH, and one uses Kb and the other uses Ka. And notice how this is also swapped. Conjugate acid go on top and base go on bottom, and this is conjugate base go on top, acid go on bottom. So we're going to be using this equation because our equation is going to be NH4OH plus NH4Cl. Cl minus HCl is a strong acid, so this is going to be weak conjugate base. So Cl is not going to be included. And you'll be using this equation whenever you're dealing with a basic solution. So now let's use this equation and write POH. Right? We're given with pH, so let's give POH for 14 minus 9.5. And how do we know this is basic? It's because we have a pH. No. So the POH is going to be 4.5, which is equal to the negative log of Kb. Alright, here, since we're already given the Kb, we can just use take the negative log of that to find the Ka. So negative log of 1.8 e to the negative fifth power is going to be 4.74. Now plus the log of the conjugate acid on top and the base on bottom. Our conjugate acid is going to be NH4Cl, the one with the Cl, and our original base is going to be the NH4OH with the NH4OH. So that is going to be equals 4.74. Actually, I just subtract both sides with 4.5. 4.5 minus 4.74, which equals negative 0.24 is equal to log of x divided by, and down there is going to be 2.0. We're given with 2.0 molar concentration. So negative 0.24 times 2.0 is going to be, no, sorry, 10 to the negative 0.24 power is going to be 0.575, and times that by 2 will give you 1.15. So x is equal to 1.15 molar concentration. Now we need to convert this to grams. Actually, no, there's a better way to do it. 1.15, we have molar, right? Molar is molar times volume, 1V. So we need to convert from moles times the volume, which this will be 1 liter actually. Do molar times liters to get you moles, and then from the moles you can convert to grams, which will still give us the 62 grams because we're in a 1 liter solution. So our number of moles is equal to number of molar. Our number of molar is equal to number of moles. But if you're not in a 1.0 solution, remember to convert to moles first and then to grams, because moles divided by liters will give you grams over liters and not the grams that you should be looking for. So our final answer to this problem is 62 grams of ammonium chloride, and this 53.5 is just straight from the periodic table, N plus 4HS plus Cl, and that is how you do this problem. Alright, next, what is the pH of solution in which 5.0 ml of 0.4 molar solution of HCl is added to 75 milliliters of 0.5 molar solution of ammonium hydroxide? Ammonium hydroxide is NH4OH. So let's see here. H, first of all, this Cl will not be included because it's a weak conjugate base, and we have NH4OH. Alright, so now this time we're adding two different solutions together. So we're gonna have to add a rice jar first. But first, let's convert everything into moles in order to start working with the rice jar. Alright, we have 25 milliliters. 1 liter has 1,000 milliliters, and then we convert into 0.4 molar. 0.4 moles, yeah, 0.4 moles on top per 1 liter. ml cancel out, L and L cancel out, leaving us with moles. So 25 divided by 1K times 0.4 will give you 0.01. 0.01, and this is our answer in moles. Next, we have 75 milliliters of 1 liter, 1,000 milliliters. And this time it's going to be 0.5 moles per 1 liter, aka 0.5 molar. So 75 divided by 1K times 0.5 gives you 0.0375 moles. Now let's pull up an RBCA chart. Now remember, ammonium hydroxide, which is our same thing up there. Actually, I should have told you guys earlier. Over here, ammonium hydroxide. Ammonium hydroxide is NH4OH, but by now you should know that NH3 plus H2O forms NH4OH. But this doesn't exist in nature, so it's gonna form right back into these two. So whenever you see NH4OH, it is basically NH3 plus H2O. Now we don't really care about H2O, so we're just gonna take our NH3. So ammonium hydroxide is actually NH3, and we're gonna have H3O plus, because remember this H turned into H3O plus because they're the same thing, plus NH3. That is gonna be our reaction, and this is gonna turn into NH4 plus H2O. Now we do the moles. We have 0.01 of 25 milliliters, which is HCl. So our H2O plus is going to be 0.01. So here it's going to be 0.01, and this will be 0.0375. NH4 we're going to have 0, and this we're also going to have 0. Next, we're going to subtract both sides by a smaller one, which will be 0.01. Now this is going to be 0, and 0.0375 minus 0.01 give you 0.0275. And plus 0.01 over here, which will be 0.01. Now convert these back to moles. After adding up our solutions, we now have 25 milliliters, and 75 milliliters. So now we have 100 milliliters. Now we're going to divide 0.0275 divided by 100 milliliters, which will be, no, divided by 0.1 liter, sorry. It's moles divided by liters, so it's going to be liter. So 0.0275 divided by 0.1 is going to be 0.275. And 0.01 divided by 0.1 is going to be 0.1. And these are going to be molar. Okay, now we can pull up a rice chart. Now our new reaction here, since we already used up all the H2O plus, to find pH we can just use the normal reaction. NH3 plus H2O this time will form NH4 plus OH minus. NH3 we're going to use the previous molar concentration, which is 0.275, and water we're not going to care. NH4 we're going to use the 0.1. Now it's going to be minus X, 0 plus X, 0 plus X, 0.275 minus X, maybe 0.1 plus X, and it's going to be X over here. Now we're dealing with NH4, right? We're doing KB equation. So we're going to have to use the conjugate base Ka of NH4 plus and use a Kb of that. Up here, okay. So Ka for NH4 plus is 5.6 times 10 to the negative 10th. So 5.6 times 10 to the negative 10th. 1.0 times 10 to the negative 14th divided by 5.6 times 10 to the negative 10th. So 1.0 divided by 5.6 e to the negative 10th up to 1.0 e to the negative 14th. It's going to give you 1.79 times 10 to the negative 5th is equal to x times 0.1 divided by 0.275. So we multiply this answer by 0.275 and divide that by 0.1. Finally, we're going to take the negative log of that, which will give us 4.3. So negative log of our x solution is going to be 4.3. But that is a POH because we're using base. So we're going to do 14 minus 4.31 actually. 14 minus that, which will give us 9.69 pH. Now finally, it said a student adds 14.03 grams of solid KOH. What is the pH of the resulting buffer? Alright, so 14.03 grams of KOH is going to be equal to 1 mole of KOH. Let's see how much KOH weighs. K is 39.1 plus 16 plus H 1.01. We'll give you 56.11. So 14.03 divided by 46.11 is going to be grams out here. Grams, which will be equal to 0.25. And this is moles. Next, we have 500 milliliters, and 1 liter has 1,000 milliliters. And then you have 2.4 moles of acetic acid HC2H3O2 per 1 liter. So 500 divided by 1,000 times 2.4, which give you 1.2 moles. Alright, next, Rebecca chart, ABCA. Because we have two different solutions, you show them consumption of the moles. So we have, let's see, K will not be included, and we have acetic acid. So it's going to be HC2H3O2 plus OH minus, forming C2H3O2 minus plus H2O. So our moles, let's see, this is acid, so it's going to be 1.2 moles over here, 0.25 moles over here, and 0, and cross out this. So minus 0.25 is going to be 0 over here, 1.2 minus 0.25. 1.2 minus 0.25 will be 0.95, and this will be plus 0.25, this will be 0.25. Alright, what is our new solution? What is our new molarity? Well, new concentration of volume. So we have 500 ml plus, okay, 500 ml is our total volume together. So we divide both of these by 500, 0.5 liters. So 0.95 divided by 0.5. Which this will give you 1.9 molar, and this 0.25 divided by 0.5 will give you 0.5 molar. And this is acetic acid, and that's acetic base. Again, now we have no OH minus, so we're just gonna write a normal reaction of acetic acid with water to find the pH. Plus H2O, forming C2H3 O2 minus plus H3O plus. Okay, now this, let's use 1.9 molar as given in the beginning. This will be 0.5 molar. This is going to be crossed out. This is going to be 0 because we never had any H2O plus. Now this is going to be minus x. It's going to be 1.9 minus x. It's going to be plus x, 0.5 plus x, x. Now what is our K for acetic acid? K for acetic acid is C2H3O2 minus 1.8 times 10 to the negative fifth. 1.8 times 10 to the negative fifth is equal to x times 0.5 divided by 1.9. So 1.8 e to the negative fifth times 1.9 divided by 0.5, which will give you a pH. No, which will give you x value of 6.84 times 10 to the negative fifth. Take the negative log of that, and we get a pH of 4.16. Now another method that I could have used would be the HH method. So I'm going to quickly show how to do that. Personally, I like to do that way better, but I just want to show you the rice chart method again. So for the H equation, we can stop right here once we found the molar of everything. So we're going to have, because in the end we'll be producing H2O plus, we're going to be using the normal pH equals pKa plus the log of, let's see, the normal one will be conjugate base on top and acid on the bottom. So conjugate base on top and acid on bottom. So this will be pKa, right? We found the K, so let's take the negative log of 1.8 e to the negative fifth, which will be 4.74, which is pH is going to be equal to 4.74 plus the log of conjugate base, which is, our conjugate base is C2H3O2 minus acetic ion. So log of, we have 0.5 molar divided by 1.9 molar will be negative 0.57998. Right. And then if we add this to 4.74, you'll get a pH of equal to 4.16. And look, it's the same answer as we got over here. So this HH equation is actually the quicker method. So on the AP exam, I'll prefer this way. But this is the rice chart so that you can have everything written out in front of you. And that's it for this video on our extra buffer practice. Thank you for watching.